This is another May 2016 examination question, problem 3 from paper 1. Please take a moment, try this problem, pause the video, resume when you're ready to look at the answer. So it's saying, in which is NaOH the limiting reagent? Reagent, remember, is the same word as reactant. Don't want to forget that that means the same thing. We're looking for the limiting reactant, which really means that we are talking about stoichiometry. Limiting reactions are dealing with stoichiometry, which means we need to have a balanced reaction. As always, IB is trying to be nice to us by giving us things that we should easily know and not too much of any one thing. So they're only giving us two possible reagents or reactants. All of these reactants have NaOH as one of the reactants. And then we have two different products. We have H2SO4 as well as HNO3. So we're going to have to do two balanced reactions to see the difference between the two before we start looking at the amounts of each of them that we have. So anytime you have an acid, like all of these are, so H2SO4 is our acid, reacting with a base that contains either an oxide or a hydroxide, you are going to form two products. It is going to be water and a salt. And the salt is the leftover stuff when the hydrogen from the acid and the hydroxide from the base form the H2O. So my leftover stuff here, I need to look at my periodic table to look at the oxidation number or the charge that it should have, as well as remember back to what the charges of the sulfate ion is, the polyatomic ion, or I could cheat and know that hydrogen is a 1+, so that must mean to balance that out, that was a 2-. So I've got Na, metals are always listed first, with a 1+ oxidation number. It's an alkali metal, so it's a 1+ oxidation number. And SO4, being a polyatomic ion, is a 2-. So my second product, my salt, which is always, again, the product of an acid with a base containing an oxide or a hydroxide reaction, Na2SO4. And so if we balance this out, I'm going to put a 2 in front of my NaOH. Now my NAs are balanced. I have one SO4 group on both sides, so that's good. So I've got 2 oxygens because the 2 gets multiplied through here. So I'm going to put a 2 out front there. And I have 4 hydrogens there, which is good because I've got the 2 from there as well as 2 times the 1 there, so 2 plus 2 is 4. So now I've got a balanced equation there. So my ratio between sulfuric acid and NaOH is 1:2, and that molar ratio is going to come in handy as we are determining the amount of the limiting. Okay, my next part is looking at my second equation, and again it's an acid. HNO3 is nitric acid. HNO3, this time reacting with NaOH, it's going to form again water plus the salt, the leftover stuff. So this time my hydrogen and my hydroxide formed water there. My leftover stuff is the Na and the NO3. Na has an oxidation number of 1+. NO3 is a polyatomic ion with a charge of 1-, and so my salt is NaNO3. Acid plus a base that contains a hydroxide or an oxide forms water and a salt. There, we've got it totally. Now I just need to check for balancing. So my NO3, there's 1 here, 1 here, that's good. Na, 1 there, 1 there, that's good. Hydrogen, I've got 1 plus 1, that's 2. I've got 2 there, so that's good. My oxygen, there's 1 there, One there, that's good. Remember, when you're balancing equations, if there's polyatomic ions that stay the same on both sides, treat them as a group. It will make your balancing much easier. So in this problem, I have a 1-to-1 molar ratio between the nitric acid and the sodium nitrate. So now I can take a look at the relationship between these things. We want to pick a product that we're going to compare to because the limiting reagent limits one of the products. So I'm just going to pick as my product in both of these the salt. So there's 1 mole of each of my salts. So my ratio 1-to-2 and then to 1-to-1. So let's take a look. If I have 0.2 moles of NaOH, and I want to know how many moles of sodium sulfate that forms, I know that I have a 2 as my coefficient there. So for every 2 moles of NaOH, I have 1 mole of Na2SO4. So that's 1/2 of my 0.2, that's 0.1 moles of Na2SO4. And then I want to look at my other reactant to see, so we got that one taken care of. I want to look at this one, and I'm starting with 0.1 moles of H2SO4, and I'm looking at my ratio. There's 1 mole of H2SO4 for every 1 mole of sodium nitrate. Again, I have to have the same product that I'm comparing them to, otherwise I won't get a correct answer. And that is just 0.1 moles of Na2SO4. So both of these give me the same amount, so that is not going to be my answer. They would both be the limiting reagent because they're both limiting the amount of Na2SO4 that we can get out. The next one, we've already calculated the 0.1 moles of H2SO4. We've got that here as our comparison. We just have to compare with the 0.1. So 0.1 moles of NaOH. This part is going to be the exact same that it was there. So 1 mole of Na2SO4 for every 2 moles of NaOH. So in this instance, half of that is 0.05 moles of NaOH. So this time I'm comparing these two numbers, the 1 mole of Na2SO4 that's caused by the H2SO4 and the 0.5 moles of NaOH caused by the 0.1 moles of NaOH. And sure enough, the biggest amount of, oops, I wrote that wrong again, sorry, Na2SO4 is what is caused by that 0.1 moles of NaOH. So B should be our answer because it has limited the amount of product that I can get out. Never hurts to double check my answers though, so I'm going to take a look at my last two. This time we've still got, we've changed the ratio of NaOH, so we're going to have to redo them. I was hoping that we could do a shortcut like we did on this one, but we can't. So we're going to start out, let me use a different color just to make it a little bit easier to see. We're going to start out with 0.2 moles of NaOH. And that again, this time it's a 1-to-1 ratio, 1-to-1. Saving some time writing, we got 0.2 moles of the product that we can expect to get out. And then our other one is 0.1 moles of HNO3. The HNO3 is again a 1-to-1. We have 0.1 moles of NaNO3 that we could get out with the nitric acid, and so this one is limiting, which means that C is not the correct answer. And then finally, again, here they were nice to us. They kept those numbers the same, so I'm going to be comparing to this 0.1 this time. It's got 0.1 moles of NaOH. And again, 1-to-1 ratio, I get 0.1 moles of NaNO3 in this one, which means they're the same. So that is not our answer either. So sure enough, B was the correct answer. We couldn't do anything to prove otherwise.